The trigonometric ratios, the way you've learned them first time you made acquaintance with them, were introduced through the idea of a ratio in a right angle triangle. Okay, so consider this right angle triangle with this being the right angle. And let's pick one of these acute angles inside of it, and let's call it theta. I'm going to pick this one here. The same explanation would work for either of those angles, but the next labeling will be dependent on the position of that angle in this triangle. So now, in relation to this angle that I picked here, the side that's opposing this angle but makes the right angle triangle, one of these legs, it's called the opposite side to this angle. And then the side that's beside it, it's called the adjacent angle. Okay? And then the longest side in a right angle triangle, it's called the hypotenuse, in short, H. Okay. And then what we have noticed with the right angle triangle is that these ratios that we can create between the sides of the right angle triangle, they're staying constant, they're staying the same if you are looking at the same angle, but a different triangle, a similar triangle. So if I extend or make a shorter triangle like this that has, again, the same right angle there, the same corner angle here, and now this is the tinier opposite side, this is the tinier adjacent side, and this is going to be a tinier hypotenuse. The ratios between O and A will be the same ratio between this O and this A of the bigger triangle, right? So it doesn't really matter how big the triangle is. If we're talking about the same angle, the ratios of those sides in the triangle staying constant. And because they are constant now, they deserve a name, okay? So what should I call the ratio opposite divided by adjacent? Because that's just a little bit too long for me to say. So I'm going to call it the tangent ratio. What should I call the ratio of the side opposite divided by the hypotenuse? It's a little bit too, it's a mouthful, right? Like, let's call it the sine of the angle, okay? That will give me that value, that ratio. And the same thing for the cosine is adjacent over hypotenuse. And then North Americans like to memorize a lot of mnemonics, and that's great, right? So how can we memorize how we set up the ratios so we don't forget which one is which? It's SOHCAHTOA, right? A lot of you have heard about this one. So SOHCAHTOA helps you remember how to set up the ratio. The ratio for sine, so S stands for sine. You're setting it up like this, opposite divided by hypotenuse, okay? The ratio of cosine of a certain angle, of angle theta in this case, is the adjacent divided by hypotenuse. The ratio for tangent is the opposite divided by adjacent, okay? Make sense? We've done this way back, I think, even in maybe grade 9. So this definition of our trigonometric ratios is a little bit restricted because it restricts us to only talk about values or trigonometric ratios for angles that are acute, so less than 90 degrees, because we are working in a triangle, right? And then we notice later on with more study of trigonometry that actually we can work with these ratios outside of a triangle. They actually apply throughout, right? Because we discovered the function that's based on these as well, right? So the restrictiveness, it comes from the fact that we can only go between 0 and 90 degrees angles. And then once we discover trigonometric functions, then these will allow calculations for any angle. Now, again, this is a bit of review. What I want us to focus a little bit before we go forward is understanding the notation that we use for trigonometric ratios, okay? And I'm giving you this one example, and I'm also going to ask you to plug into your calculator this one example, just make sure that we understand, or we make sure that our calculators are set up in the right unit for our angles. So when we say sine or cosine or tangent, we always have to follow it by an input, because that's, now we know what a function is. It's followed by an input for that function. Or in the trigonometric ratios explanation or definition, you are calculating that ratio for a particular angle. It doesn't exist without that angle, okay? So we say sine of 30 degrees. This is my input. We say sine of 30 degrees equals to, or has the value of 0.5. And if this is the input, the 30 degrees, the 0.5 or the 1/2 is the output. So if you press sine, it has to get an angle. Doesn't matter if it's in a different unit, because now you know the angles comes with different units. Now in degrees, they can also come with radians as well, right? It doesn't matter what it is, but it has to be an angle that goes in it, okay? A number that represents an angle. And then we get a value for that trigonometric relation here. So input, or sometimes we call that an argument, is going to be an angle. Of course, represented by a number. Output is always the value of that calculation, a number. The output is just the calculated trigonometric ratio. And you can get it like this, doesn't mean it's not a ratio. Still, like you can still create that ratio for the 0.5 or for a more interesting looking number. And of course, the word ratio comes from the fact that we started again with triangles, and these have determined lengths, right? So when I say opposite divided by hypotenuse, I can measure the opposite side, and I can measure the hypotenuse, right? So definitely I can create that ratio. Okay, here are the angles that we're gonna work with, and their corresponding exact values that you will need to know, memorize. So you have them both in radians and in degrees. So those are the angles in degrees, and these are the angles in radians. So how you read this table, you just look at the sine, that's the trig function that you're calculating for. Alpha is just the name for the angle, and these are the angles of your choice. So if I say, what's sine of 60 degrees? You just go here and it's square root of 3/2. What's tangent of 270 degrees? This line means it does not exist. Okay, so when you see this line here, that means there's no value for it. This is for us D and E. And then we will talk about it, why it does not exist a bit later on. Okay, so do you need to memorize these as a table? No, I'll give you better tools to memorize these values, but in the end, these are it. These are all the values you need to know by heart. All of the angles we will be talking about. And of course, 30, 45, 60, 90, 180, 270, and 360 will come with their families of angles. Of course, these ones just extra rotations, but the ones that are not quadrantals, they have families of angles. Okay, now we're kind of ready to go into more of trigonometry of grade 12. So equation of a circle. This is review from grade 11. So let's think of placing a point anywhere we really would like on this circle that's drawn on the Cartesian plane. And the origin of the Cartesian plane is also the center of the circle, okay? This point can be anywhere. You can draw it here or here, but I'm just going to do it here for the simplicity reasons. And then I can unite the center with that point that I chose. And obviously, this is going to be the radius of the circle, right? So the distance from the center of the circle to a point on the circle is called the radius, right? Then, if I draw the perpendicular to the x-axis, I really am showing how high up along the y-axis or how low along the y-axis my point P is. So I'm describing the y coordinate of this point P, right? That's y. Because P has some xy coordinates, right? So that's y. And then here on the x-axis, where those two lines meet, I am showing really, or we're seeing how big the x is for this point P. So the point has a location in the Cartesian plane, xy location. Make sense? Okay. Also, once we do this, we can see we drew a triangle, right? And then at the center of this triangle, we have this theta, let's call it an angle, a central angle theta, that now we can calculate trigonometric ratios for using this circle, because we can create those ratios in the right angle triangle. This is a right angle triangle, right? So opposite to the theta is y, right? So that's going to be the opposite side. Adjacent to theta is the x coordinate. So that's the a. Well, we've talked a little bit earlier about the review. And the radius of these angles is going to be always the hypotenuse of these triangles that you can create. And now, instead of saying that sine of the angle theta is opposite divided by hypotenuse, we're going to use the coordinates and the radius. So opposite over hypotenuse really is y over r. Okay, so we're going to do that, y over r. For the cosine value or ratio, we're going to do adjacent over hypotenuse, which is x over r in this situation. And the tangent is opposite over adjacent, which is y over x, but x cannot be 0, okay? So we have that exception because we cannot divide by 0. In both of these situations, radius will never be 0, so we don't have that exception, but here x coordinate can be 0, so then we have to make sure we say that. Okay. Now, why is this useful? Well, because it's kind of moving away from geometry and it brings a bridge between geometry and algebra through the means of trigonometry, right? It's called analytical geometry, basically, when you kind of make that crossing, okay? And then, of course, it has lots of application. We are trying to move towards the unit circle and the calculation of various trigonometric values using these ratios, but more, again, a bit more, even simpler than this, using the unit circle. Now, I can describe the x and the y, like the position of any point on the circle, using the rearranged values of these ratios. So for y, just have to cross multiply here. So you can say it's r times sine of theta. So if you know the angle and if you know the radius of that circle, you can figure out the position y for a point. And for the other relationship, for the x, if you cross multiply, you get r times cosine of theta. So again, if you know the central angle and standard position and the radius of the circle, you can figure out also the position of x. So you can locate any point just by knowing those two, the theta and the radius. Okay, so it gives us just a little extra information. So we can write any coordinates now using these relations. So just notice that x is with cos though, because For my brain, I always want to start with sine for some reason, but X is the cos relation and Y is the sine relation, okay? So coordinates will be r cos of theta, r sine of theta for the point, which again represents X, Y in the Cartesian plane. And we can write the equation of the unit of the circle with a center of 0, 0 as x squared plus y squared equals r squared. And that is represented by any, or for any circle of any radius. But it has to be with a center at 0, 0. And we have the unit circle on the next page, but what I want to again show, because now hopefully it makes sense, this little diagram, I can choose a point anywhere in any quadrant, okay? Let's say I choose a point here, okay? Let's call it K, okay? And then we create a triangle. This is theta, right? That relationship will always happen, okay? In relation to theta, this is gonna be the y, right? That's gonna be the x, this is the r, right? So sine of this theta, right, is gonna be opposite, which is y divided by r. Cosine of this theta is gonna be the x divided by the r, right? So doesn't matter really where on the circle you are, these relationships will stand, okay? But you have to talk about this angle right there, the central angle. Okay, so unit circle now. So we're simplifying a little bit the circle by saying that what happens is instead of any circle that has any radius length, we're just gonna simplify it to the unit circle, which will have the radius equal to 1. Well, what would happen is it will give us a very easy and simple direct way to figure out the values of our trigonometric function, okay? Because again, if I choose a point P here, and now this is my radius, but we already said it's 1, right? This is the unit circle. Any trigonometric value of cos or sine, in this case, we'll have to use the 1 as the hypotenuse, right? So this is the y, and that is the x. So for the sine of theta, I have to do y divided by 1. So basically, y coordinate is the value of the sine of that angle. For the cosine, I have to do x divided by hypotenuse, so x divided by 1, so just x. So the value of that x coordinate is just the value of the cosine of that angle. The tangent, because it's not dependent on r, will be the same thing, right? It's gonna be y over x. Again, x cannot be 0. So any point now on this unit circle with the radius 1 would just have the xy coordinate defined by the trigonometric values of cosine and sine in that order. So cosine of theta is going to give you your x coordinate, and then sine of that angle theta will give you the y coordinate, or vice versa. If you know the x and y coordinate on the unit circle, you actually know the value of cosine and the value of sine for that particular central angle in the unit circle. Make sense? Okay. This is a bit of the tangent explanation. So you have y over x. And since we know y is sine of theta and cosine is x, then the relationship becomes sine over cos, okay? And then now cos of theta cannot be 0. We'll come back to the NPVs later on when we know more values on the unit circle. But yes, there are some restrictions. Okay, so now let's take that information, the fact that any point on the unit circle will have these coordinates. The value of the cosine is my x coordinate, and the value of the sine of that angle is my y coordinate. And try to figure out any of the missing pieces here for each of the angles that I have a list here on these pages. So we want to find out the coordinates on the unit circle for various points on the terminal arm of specific special angle families. Let's start with the quadrantal angles, okay? So let's pick one that's a bit easier to see. So let's pick this angle right there. Okay, and this is the point that I'm trying to get to, this point right there, and the angle is 90 degrees. So P 90 degrees, which is the equivalent of P of pi over 2 in radians. What are the coordinates on the Cartesian plane of this point? X is 0, and the y is 1. Now, by knowing these coordinates, I also know what is sine of 90 degrees, what's cosine of 90 degrees, and I can calculate what's tangent of 90 degrees, okay, in a bit. I can look at the calculation for it, okay? Now, how do I know what sine of 90 is? Well, sine is the y coordinate of these points on the unit circle. So what's my y coordinate? 1. So the value of sine of 90 is 1, because that's it, okay? So that's what we talked about on the previous page in those notes. That's the utility of the unit circle. Now, what's the cosine value at 90 degrees? It's 0, because that's the x. Cosine values are x's, okay? So that's 0. We know that straight from knowing that location, the xy location, okay? Now for tangent, what you gotta do is y over x, right? So 1 over 0 does not exist, or we can say undefined, okay? Undefined. So at 90 degrees, we already know that tangent values will be undefined. But now if we take it a step further, all of the other coterminal angles with 90 degrees also will have to be excluded, right? Because if you just rotate, but then you end up in the same position, the point will be exactly the same, right? Does that make sense? So you're still going to end up in the same situation as doing 1 over 0. You cannot divide by 0. And it doesn't matter, as long as your terminal arm in the same position, you have again the same situation for, or the same values for your sine and cos. Therefore, the tangent values will be undefined at all of those angles. Clear? Okay, now let's choose another point right here. So the point coordinates for the angle 180, or the point at pi. What are the coordinates of that point? You have to see the number line right here. The number line. And this is 1, that's -1, this is -1, that's 1. I can't do the 2 because it's like zoomed in, right? That's why you can see it. It's -1, 0. Clear? Now, if I ask you, what's cosine of pi? What are you going to tell me? -1. Why? It's because on the unit circle, right, I can read the cosine value from the x coordinates of the points on the unit circle. It's strictly, like, it's just directly there. Okay, what's sine of 180? 0. Why? Because it's y. Sines are y, cosines are x's. Just to show you that it can be either or, but it's really the same position, right? Now, what's tangent of pi? It's 0 because we have to do 0 divided by -1, which is 0, right? For that one, you have to go to the calculation. Make sense? And you can apply the same principle for all of the quadrantal angles. The only one that I really want to, like, again, work on and show you is the 270 or 3 pi over 2. Because what happens at tangent for that one? What's tangent of 270? It's going to be y over x. What's x for this? 0. What's y? -1. If I do -1 divided by 0, does not exist or undefined again. So again, tangent doesn't have values at all of the coterminal angles with 270 or 3 pi over 2. Now we can put these together and say that at all of the odd counts of pi over 2, you won't have any values for tangent, because here's pi over 2, here's 3 pi over 2. So it's 1 pi over 2, skip 3 pi over 2. Then it skipped again to 5 pi over 2, and skip again to 7 pi over 2. So how do I say odd counts? It's like a special way to write it in number theory. You say 2 times, and let's put a number k, and then always add 1. It will always define an odd number. So 2 times k plus 1 always refers to an odd number. So if you replace k with any integer, that calculation will always give you an odd number. Try it. Replace k with 0, what do you get? 1. Replace k with 3. You get 7, right? So you always get an odd number in this sort of format, right? So to catch all of these odd angles, right, of pi over 2 odd multiples, we say take that and multiply by pi over 2. Okay, and for all of these angles, tangent won't be defined. Replace pi over 2 and 90, it's that, it's the same way. All of the odd counts of 90 degrees. Okay, where k belongs to z, because we want integers for the counts. This k that you choose is just an integer. 1, 2, 3, 4, 0, -1, -2. You don't want to choose 0.5. Okay, that's not what we're talking about. Does that make sense? Okay, so these are all exclusions for tangent. So on the previous page, what I was saying, we'll get to it. That's what it means. The NPVs for tangent are all of the odd multiples of pi over 2 or 90 degrees. All of the odds for the 90s. Sometimes I feel like if I say the same thing twice, it makes more sense. I repeat myself. Okay, but yeah, we will come back to this over and over again, because of course we will encounter it. It's one of those exceptions that will come questions, and we have to be aware of it, especially when we have to do equations. So I hope that makes sense for quadrantal angles and how the points work. Now let's work with another kind of angle, the pi over 6 or 30 degrees, or any family of angle for those 30 degrees. So that's the angle right there. And the point over here, I'll tell you what it is, but there's all different ways of actually figuring out. So if you're interested, I can actually show you how we can figure the values out. The point is square root of 3 over 2 and 1/2. So that's what the position of this point is for the angle 30 degrees. Now, if I ask you what is, again, this is the 30 degrees or pi over 6 angle. If I ask you what is sine of, what's sine of 30 degrees? right, it's 1/2. Why? That's right, because sine of an angle on the unit circle is the y coordinate of any point on the unit circle, okay? And the cosine of any angle, central angle on the unit circle, like the way we draw it here, is the x coordinate. Okay, that's really all you need to know about the unit circles. If you know that, you know 80% of the things that you will do with the unit circle. Okay? So then now if I ask you what's cosine of pi/6, which is again the same thing, it's still 30 degrees, but in radians. What's cosine of pi/6? Yeah, square root of 3/2. That's what it is, the value of it. Okay. Makes sense? Why? Because it's the x coordinate of that point. Okay. Where the radius is formed at 30 degrees. Okay, what's a tangent of 30 degrees? So 1/2 over square root of 3/2. The 2's will cancel, 1 over square root of 3, like that. That's a good enough answer, but most of the times you will see it and you would be asked for it in the rationalized form. Okay. How do we rationalize square root of 3? We multiply by square root of 3 where we need it, and then we have to double it up at the top. So overall, this value is 1. Because I'm not allowed to introduce something new, right? I can only multiply by 1, so I can conserve the same value that I had before, right? Does that make sense? I can't add 1, because if I add 1, I'm changing the 1 over square root of 3, because I add 1. But I can multiply by 1, because that stays the same. Clear? So this equals to 1, but then we're rationalizing because we don't want to divide by square roots. And that's why we're doing this. Yeah, go ahead. You can ask, don't have to wait for me. Yeah? What part do you want me to say? Square root of 2 over there? Yeah. Oh, how did I got that? I actually didn't explain how I got that. I just told you that's the point of that. But we can make a parenthesis since we are taking it really slow, okay? I can show you one of the ways that we can deduct or kind of avoid not to memorize these ones, okay? You have to know a few geometry rules, but yeah, you'll be able to follow through. So in a right angle triangle, and this is 30 degrees right there, okay? The opposite leg to the 30-degree angle is actually half of the hypotenuse. So whatever length this is, it's always going to be half of that. Or whatever length this is going to be half of the hypotenuse. Does that make sense? Oh yeah, the opposite leg to 30-degree angle is always half of the hypotenuse. And that's why I'm saying you have to know some geometry rules, okay? So if we choose this to be 1, for example, then we know for sure this is going to be 1/2 by following that rule. Okay, now how do I know the third of it? Well, apply the Pythagorean theorem, right? X squared plus y squared equals r squared and the square, but you had it like this: a squared plus b squared equals c squared, right? So then our a is 1/2, our b is unknown, and c is 1. So b squared is 1 minus 1/2. Square them. B is 1 minus 1/4, so 3/4. Square root both sides. B is square root of 3/2, right? That's one way to kind of like remember the values. I feel like it's useful when you first introduce these values to somebody, but once you know the unit circle, like you just need to like sort of, yeah, this is what it is. You won't get it filled, but you'll know how to fill it. Like I trust I will give you enough tools to quickly be able to fill it up entirely in like a minute, less than a minute. Okay. So yeah, you'll know how to figure out. Just what's more important is not like how you're gonna memorize this, because you will, okay, you'll know them. It's like, how do I use them to answer questions? Because you will have the unit circle in front of you, you will build it and you'll know how to build it. Like, do I know how to read it? So the reason why I'm insisting on this one, I'm asking you these questions, because I want to keep insisting on saying, where do I find the value of sine if I know x, y, right? Because you will know the x and the y, right? So which one is sine, which one is cosine, right? The sine is the y, the cosine is the x, right? So you have to know that directly. How do I find tangent? Oh, you just have to divide these two and that's it, okay? Clear? Okay. Now, what's cool about our family of angles and their reference angles that unites them, like if you extend now that x, remember we talked about these x's last class, you would have a bunch of 30 degrees over here, right? Does that make sense? So they will be related in absolute value. So you would still have square root of 3 over 2 and 1/2 for all of them. But something will be different. Can you tell me what do you think will be different? The signs, why? That's right, they're different quadrants, right? So in quadrant 2, your x's are negative and your y's are positive, right? So this would be negative square root of 3 over 2 and 1/2, right? In quadrant 3, both the x and y's are negative. So both of these will be negative. So if I ask you, what is sine of, what's this angle here? From here all the way to quadrant 3, sine of 100 and 210. Okay, that's right, it's 210. 210 in quadrant 3. What's going to be the sine value for that angle? Negative 1/2, right? For sines are y's, okay? Yeah. So we will know immediately it's 1/2, but then we have to remember that if it's a family or a member of the family of angles that lives in a different quadrant, we always have to think about the sign, right? Too. It's like, oh, quadrant 3, I'm gonna get a negative value for my 1/2, right? Oh, it's quadrant 2, it still stays as positive 1/2. Oh, it's quadrant 4, x's are positives, but y's are negative. So I have to be aware of my signs as well. So what we will do, we will memorize everything in quadrant 1, because all of the other ones are just copy and paste, exception making the signs, because you're in different quadrants. That's what I'm saying. You'll be able to fill up the unit circle really quickly, because it's just memorizing 3 points and then copy and paste with the appropriate signs. Clear? I hope so. Okay, moving on then. 2 pi over 4, 45 degrees. That's what pi over 4 is. And the point coordinate is square root of 2 over 2 and square root of 2 over 2. These are easy to remember for 45 degrees. And this is easy with the same sort of, if you're kind of wondering, how do I know those points? If this is 90 and these are equal because you have 45 and 45, choose a really simple value first. Because remember, ratios are consistent. Doesn't matter if you expand this into a similar triangle or not, right? Yeah, choose one here, choose one there. And when you do the calculation using Pythagorean theorem, you're going to get this to be square root of 2, right? And then yes, you'll get the right, you get 1 over square root of 2, but then when you rationalize, you get square root of 2 over 2. Okay, so you can kind of put on a note somewhere that 1 over square root of 2 is the same thing as square root of 2 over 2. It's just a rationalized form of one another. Okay. Okay, so now question for you, what is the sine of 45 degrees? Square root of 2 over 2. What is cosine of pi over 4? Square root of 2 over 2. Okay, now let me make it a little more difficult now. Family of angles. I'm just going to do the radians because I'm pretty sure the degrees are a little bit easier to count for you, okay? So this here, this angle in quadrant 2, the same family, that is 3 pi over 4. This one here is 5 pi over 4. And this one in quadrant 4 is 7, you said? Pi over 4, okay? So now, what is cosine of 3 pi over 4? Negative root 2 over 2. Agreed, everyone? Yes, okay, why? Because if I put the point, the same values, square root of 2 over 2, square root of 2 over 2, the point values comes with a negative for the first one for x and the positive for the y. Cosine values are the x's, right? So that's the one that I'm choosing, the x. Clear? Okay. If I ask you, what is sine of 7 pi over 4? What you're going to say? So we're going to say root 2 over 2, and then we stop and think, okay, 7 pi over 4 is an angle in quadrant 4. I'm needing the y coordinate, okay, because that's the sine value, the y coordinate. What are the y coordinate signs in quadrant 4? Negative. And that's one way of thinking about these questions. Family of pi over 3. Pi over 3 is 60 degrees. And the 60 degrees values are pretty much the same as your 30-degree values because this is the angle right here, the 60. So they're just switched around in terms of the opposite adjacent, right? So your point will be 1/2, comma, square root of 3 over 2. And let's create the family as well. These are all the theta r's. And the count is pi over 3. In quadrant 2, the count is 2 pi over 3. In quadrant 3 is? No. 4 pi over 3, that's right. Because here's 3 pi over 3 at pi, right? And in quadrant 4, 5 pi over 3. You can count it, but it cancels out to a quadrantal angle, so it's not the same family. You don't count it, no. Because what does a pi over 3 means? You take pi and divide it into 3 sections. So your 3 sections are these. 1, 2, 3. But here it will cancel out to 3 pi over 3, which is pi. It's not the same family of angle. They have to have the same reference angle to be in the same family, which is pi over 3 or 30 or 60 degrees. Okay, so now that we have all of them, I can ask you the questions. What is cosine of 4 pi over 3? Yeah, what is the cosine of 4 pi over 3? Sorry? Negative 1 over 2, yes, because it doesn't matter if it's sine or cosine. In quadrant 3, they're both negatives, because in quadrant 3, the coordinates are both negatives, yes? Sorry, the sine? Yes. If I ask you what is the sine of 2 pi over 3, let me change it up. Now you're looking at this angle here. Square root of 3 over 2, positive or negative? Positive, because in quadrant 2, the y values, which are sine values, are positive. Make sense? What's tangent of 5 pi over 3? something. Let's see. No, tangents we cannot take directly from the unit circle. We have to calculate or we have to memorize our calculations, right? So tangent values are y over x, right? So y is square root of 3 over 2, x is 1/2. But now, which one is positive, which one is negative? Top one is negative and the bottom one is positive. Okay, good. So then the value of tangent will be negative because you have one negative, one positive, right? And then the twos will cancel, so you have negative square root of 3 over 1 or negative square root of 3. And now we're going to put it all together. All together. Okay, the first thing I want to do is put down on the unit circle all of the central angles, both in radians and in degrees. Okay? Need some colors, and I'm kind of out of colors. This one there, do I have a black? I have a black. So I'm going to keep black for my quadrantal angles. So and then keep the colors for my other angles. So the quadrantal angles, let's start with 0. And so this is going to be 0 degrees here. And this is 0 radians. And then the next one, that's 90 degrees. And that's pi over 2 radians, that rotation. And then we're going to go to 180 or pi. And then 270 3 pi over 2. Yeah. 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2. Then the next one is 2 pi. This one is 2 pi rotation, 1 full rotation, or 360. And we can go and count those in as well. 2 pi, yes. 1 full rotation is 2 pi, and 360 in degrees. I'm going to use green now and then go through all of the family of angles for 30 degrees. So this would be the 30 degrees right there and the pi over 6 equivalent. So I'm going to color it in green. The family of 30-degree angles. Let's do this is the ones in degrees first, 30 degrees, and then this one will be 150 degrees, and this one is 210 degrees. And quadrant 4 is 330. Now they're equivalent in radians. Let's see if you can count in radians. This is 1 pi over 6. It's going to be this one over here. No. The way I do it is I go the closest route to a quadrantal angle. The one here at pi, that would be 6 pi over 6. You want one less than that, which is 5 pi over 6. That's right. Now in quadrant 3, you want one extra from 6 pi over 6, which is 7 pi over 6. And in quadrant 4, you want one less than what? The 2 pi. What's 2 pi in terms of pi over 6? That's right. So one less would be? One less than 12. Oh, yeah, 11, right? So 11 pi over 12. Right? A full rotation will be 12. 12 pi over 6, not 12, my goodness. 12 pi over, 11 pi over 6. Okay, so we're done with all of the family of angles for pi over 6. Let's do the 45 now. Do that one in blue, the 45 degree or pi over 4. Sometimes I ask the students to do this when I just show them quadrant 1 and I'm going to say, yeah, about homework for you. But since we have time, we earned it. Do it together. So 45-degree family of angles in each quadrant. 45 in quadrant 1. In quadrant 2 would be, oh, we're doing the degrees first. 135, right? And then in quadrant 3, an extra 45 from 180 to 25. 45 less than 360, 315. Now we're going to count by pi over 4. Three pi by 4. Because again, for those of you that are still kind of trying to grasp this concept, if you do a pi rotation in terms of pi over 4, you have 4 of the pi over 4s. To be in quadrant 2, you have to have 1 less than that, right? Because the count of pi over 4 will be here, 1, 2, 3, 4. Okay, if you want 1 less, it's 3 pi over 4. Yeah, I hope so. It will slowly make more and more sense. In quadrant 3, we want 1 extra than 4 pi over 4, which is 5 pi over 4. And in quadrant 4, we want 1 less than 8 pi over 4, which is 7 pi over 4. And the last series of angles will be the angles that are in the same family with 60 degrees or pi over 3 under those in red. If you're getting this, you can definitely get ahead and fill out all of the angles. $60 degrees, quadrant 2 will be 120 degrees. Quadrant 3 would be 240, and in quadrant 4, 300. Now radians. 1 pi over 3 in quadrant 2, 2 pi over 3. In quadrant 3, 4 pi over 3. Because here at pi, you had 3 pi over 3 counts, and then 1 extra, 4 pi over 3. Here you have 1 less than 6 pi over 3, right? So you would have 5 pi over 3. Okay, now we're not there. We haven't finished the unit circle. These are only the angles that we need to memorize now values for. Where did the values for our trig functions come from the unit circle? From the actual points, right? Corresponding to those angle positions, right? Every place you have an angle. So let's say the 30-degree angle, there's a point right there that has an X and Y coordinate. What is that point? Because if I know that point, I know the sine, the cos, and I can calculate the tangent straight from the unit circle. So we want to fill that in as well. So let's do that. Put the points. So at that location for the 0 degrees or 0 radians, the point is 1, 0. Because 1 is the X and 0 is the Y, right? The location. And that's like pi over 2. Then we have 0, 1 there. at pi, -1, 0, you got it, yes. And at 3 pi over 2, 0, -1. So that's going to give you anything you want in terms of those quadrantal angles for sine, cos, tangent, and other ones later on too. Okay, now for pi over 3, we have square root of 3 over 2 and 1/2. I think I did them backwards. Don't write that down backwards. We have 1/2, comma, square root of 3 over 2. Because we actually started with pi over 6 today. That's why, my bad. So 1/2 square root of 3 over 2. For pi over 4, we have square root of 2 over 2, square root of 2 over 2. And for pi over 6, we have square root of 3 over 2, comma, 1/2. Now, all we gotta do is take these points and put them in each quadrant with the appropriate signs, right? So in quadrant 2, x's are negative, y's are positive. So for the family of angles of pi over 3, you copy all of the 1/2, comma, square root of 3 over 2, and make sure you put the right signs. So -1/2 square root of 3 over 2. For the 3 pi over 4 is going to be negative square root of 2 over 2, square root of 2 over 2. Right, because you're in quadrant 2, you just do a reflection, a horizontal reflection, so x's are negative. And in quadrant 2 for 5 pi over 6 will be negative square root of 3 over 2 and 1/2. Can you show me by thumbs up? I'm not sure I'm getting from your facial expressions if this makes sense or not. This one, this way, or this way? Okay, kind of like, okay, a 60-degree thumbs up, okay. I'll take that. It gives me something. Okay, good to know. So in quadrant 3, we have both negatives. So exactly the same values from the 30-degree angle, 45, 60. Make sure you put them make sure you coordinate with their family so you don't go backwards. So this would be square root of 3 over 2, 1/2, but both negative. The 5 pi over 4 would be square root of 2 over 2 for both, but both negative. And 4 pi over 3 would be 1/2 and square root of 3 over 2, both negative. What you eating there and not sharing? Is that a Rice Krispie? Yeah. Okay. You're still buying Rice Krispies?
You know what, they won't sell at Costco.
Yeah, it's just too much temptation, right? It's like, yeah, I gotta buy some Rice Krispies.
They're good to have in the bag.
They are. Yeah.
Same with those protein bars.
Which ones?
Nature Valley.
Yeah, that's right. Yeah. Yeah, it's cute. Those are the kind of snacks I pack for my kids as lunch. That's why I was like, it's good. It's good for you. Yeah. Thanks. I don't know. I'm so boring.
It's not that.
I know. I'm kidding. No,
yeah.
It's kind of cute. Okay. So quadrant 4, back to our snack of the day, the unit circle. So in quadrant 4, x's are positive, y's are negative. So you want to do square root of 3 over 2 in 1/2, but this is the one that's negative, the 1/2, right? And then square root of 2 over 2, square root of 2 over 2, negative for the y. And the 1/2 negative square root of 3 over 2. Now, what I think it's most difficult for students is creating sort of a barrier of separation between the fractional forms of your angles, right? All of your angles in terms of pi, and understanding those are angles. And then the values of the functions are also fractions because it becomes a mush. And if I say, what's the angle that gives you the cosine value 1 over 2, you know, like you're just like, oh my God, like you have to go back to pi over 3. It's just, you know, you have to be able to separate which one is which, okay? So the CAS rule is another way of helping you out where the values of the functions are positive or negative. If you feel like the x's and the y coordinates in the different quadrants are not helpful enough, or it's if you want to synthesize a little bit that information. So we're looking at every single function value, and then we say, okay, in quadrant one, what kind of signs can we get for our functions? And we notice that in quadrant one, all of them are positive. So we say A for all. Okay, all functions are going to be positive in quadrant one. It doesn't matter what they are, right? And then we notice that in quadrant two, only the sine function, and it's reciprocal. If you do 1 over sine, that's also going to become positive, okay? So only sine is positive, and then the other ones are not, the cosine and the tangent and their corresponding reciprocals, okay? And quadrant three, only tangent is positive. The other ones are not. And in quadrant four, only cosine and its reciprocal is positive. The other ones are not. So it's a way of summarizing where my functions are positive. And then if you're looking for another one in that quadrant, then you know if it's in the quadrant where it's sine and you're looking for cosine, you know cosine will be negative because only sine is positive in quadrant two. Yeah. Yeah, you could say it's always positive, yeah. Because the negative will come from the x and the y, yeah. Now, before we go on to show you like a little shortcut, I think that's what's coming. How do I memorize all of these points really quickly? Because I promised you, you will know them really fast. What you can do as sort of homework is add on around the unit circle all of the tangent values. Because right now you have the cosine. So the x is the cosine of the theta. The y is the sine of that theta, right? For every xy, that's what you're having on the unit circle, right? How about the tangent values? All you gotta do is divide y and x, right? So for the 60-degree angle, you have to do square root of 3 over 2 divided by 1/2, which is square root of 3, right? For the 45-degree angle, if the tangent of that angle, you're going to have to divide square root of 2 over 2 divided by itself. You're going to get what? 1. And for the 30-degree angle, you're going to get the reciprocal of that because you're going to switch those ones upside down. You're going to do 1/2 divided by square root of 3 over 2. And we've done that already. We got 1 over square root of 3. And when we rationalize that, it ended up to be square root of 3 over 3, right? So those are the same format, the same value, but different formats, okay? Now you can take these and put them in each quadrant and you'll see you get different signs, okay? In quadrant 2, you'll get negatives for your tangents because one of the x is negative, the y is positive. So when you do the ratio of those two, you get a negative answer. In quadrant 3, the tangent of the tangent values that we just got are going to be positive because then both of your x and y are negative, right? So we can divide to negatives, you get positive. And in quadrant 4, again, negative for the tangent values. Okay, so these ones can be memorized as well, or can be always calculated with the values you have on the unit circle at any point in time. And you got to remember that here we have undefined. Remember that the pi over 2, all multiples of that, and 3 pi over 2, all multiples of that. You don't have a tangent value because you got to do -1 divided by 0, and you're not going to get anything good. Okay, so okay, so how I'm going to remember the points. So this is, I think I didn't invent this method. I found it too, and I was like, eureka, you know? So this is what I think is the easiest way. For the 30-degree angle, 45-degree, these ones you have to know which one is which. 60 degrees and 30-degree corresponding to pi over 6, and this one is pi over 4, and this one is pi over 3, right? So those are the angles, the central angles. What I'm gonna give you a tool is how to find those quick points there for it. Okay, now you know that all of your points are fractions, so you can just set up your fractions right away. Okay. And now starting at the top, because when you draw something, when you first learn how to maybe write cursive or not, you were always told do your lines from top to bottom, right? Always top to bottom. Do you remember that? Start at the top. No, no rules. Okay, okay. Start at the top and count to 3. So you go like this: 1, 2, 3. And then switch over to the right and just go again. 1, 2, 3 upwards. So 1, 2, 3, and then go to the right. 1, 2, 3 upwards. Okay. Now all of our fractions, if you look at them, they're all divided by 2, right? So you can just put 2's everywhere in the denominator. And then with the exception of 1, do the square roots of all of the numerators, because if you do square root of 1, it's still going to be 1. So it's not going to change anything, right? So put square root on top of 3, square root on top of the 2's here, top of 3. And that's it. You got all the points. Isn't that cool? Now for the other ones, for the quadrantal angles, you don't need that because these are easy, right? They're just points that you can see clearly what they are, right? Here at 0, you have 1, 0. Here at like 90, you have 0, 1. Here at pi, you have -1, 0. And at 270 or 3 pi over 2, you have 0, -1. So these are easy to put down, but these are the ones that confuse students all the time. Which one is which, right? And I thought that was really easy. So one more time. 1, 2, 3 lines. So this is the 60 degree. That's the 45 degree. That's the 30 degree. Okay. And you need the points for them. They're all fractions. And then you start at the top and you count to 3. 1, 2, 3. 1, 2, 3. Everything is over 2. And square roots at the top, except for 1, because that calculates to 1. And you're done. And now if I ask you, what is the sine of pi over 3, which is 60 degrees? What is it? Square root of 3 over 2, because sine values are x's on the unit circle, okay? Cosine values, sine values are y's on the unit circle. Cosine values are x's, right? So straight from the unit circle, you can always get these values. Okay, so now which one is better? Is it our unit circle, which kind of like looks intimidating at the beginning, right? It's like, holy moly, what that is. Or is this little table that I gave you at the very beginning? Or is this easier? So this one has all the values as well, right? Unit circle is a bit more intuitive, I would say, than that, right? Let's just memorize it. This is what it is. Probably based on the analysis of the triangles, not just like it wasn't just given to you. First, it was explained what the values are coming from. But then this is a bit more intuitive, I would say, more visual. Okay, so let's take a short break because even though we don't have your turn yet, I think we need it. It was 8 o'clock. Let's do 8:07. Yeah. Oh, 8:05. Because that will make it 7 minutes. Yeah, 8:05. Let's do example number 1, how to find the coordinates of a point on the unit circle using reference angles. This is going to be our normal approach for these questions. And these are the steps that you can go through. Not necessarily always in this order, but you need to know the parts of those steps of answering these questions. Now, to find the coordinates of the points for any of these angles, so the point coordinates at the angle pi, again, what you need to have is the cosine value of pi and the sine value of pi, right? Because if you know those values, you have the exact location in the Cartesian plane. Make sense? Okay. Now, if the angle is quadrantal, those values are really easy to find on the unit circle because all you have to do is like, where is pi? Oh, it's right there. What's this point if the radius is 1 in the unit circle? -1, 0, right? The coordinates of the point p theta, just -1, 0. So therefore, we have -1, 0. So quadrantal angles, a bit more straightforward, faster, easier work to do. Here? Okay. What are the coordinates of the point P 3 pi over 4? Well, again, we need cosine of 3 pi over 4 and sine of 3 pi over 4 in principle, okay? Now, how are we going to get there? Well, 3 pi over 4 is in the same family of angles with pi over 4, right? It's right here. Quadrant 2. Now, normally, when we do these kind of questions, I really don't want you to waste your time to fill up the entire unit circle for all of the family of angles, because you saw how much work that took, you know. And even if you have everything memorized, it's like really a waste of your 5 minutes in a test to fill up the entire unit circle. What you want to do is that know that the angle pi over 4 is related to the angle 3 pi over 4 by the means of the same values of the points. The only thing that's different is the signs in the different quadrants, right? So if I want the cosine of 3 pi over 4, it's going to be the same thing as cosine of its theta r, because theta r is pi over 4, which is in quadrant 1, right? So cosine of pi over 4. But because I'm in quadrant 2, cosine values are negative in quadrant 2. That equality is always true if I put that negative in front. Okay? Because again, what's cosine values are the x values, right? In quadrant 2, the x values are negative, right? Does that make sense? So now what's cosine of pi over 4? Because for that one, I memorize my unit circle in quadrant 1. You will have the square root of 2 over 2, square root of 2 over 2, right? And it's going to be negative square root of 2 over 2. How about the sine? Well, it's the same thing. Sine of 3 pi over 4 is the same thing as sine of pi over 4, even in an actual sign. They're both positive, right? Doesn't matter if you're in quadrant 1 or in quadrant 2, sign values will be positive. So that means to be positive square root of 2 over 2. So the actual point that I need to answer my question are these coordinates, the negative square root of 2 over 2 for my cosine value, and the positive square root of 2 over 2 for my sine values. And yes, I've done a bunch of extra work that I don't need to do because all of this will happen in your mind, not necessarily on paper, but that's where they're coming from. And I want you to see the relationship between a member of the family of a certain angle and the angle in quadrant 1, which can coincide with the reference angle. Okay, again, don't memorize the entire unit circle, just memorize only the first quadrant. That's the answer. The point coordinates for -5 pi over 6. So -5 pi over 6 is in the same family with pi over 6, or 30 degrees, right? But it's right here, right, in quadrant 3. Now, what is the point in quadrant 1 for the members of these families? √3/2 and 1/2. And the way I do it, it's the 30 degrees, the one closer to the x. So I go 1, 2, 3, right? So square root of 3/2 and 1/2 in my head. That's what I do it. Okay, so that's the point. Okay, all I gotta do now, I'm doing a bit less work here because now this is the approach. I need the same point, but in quadrant 3. What's gonna be that point? In quadrant 3, both x's and y's are negative, right? So this is the one that I memorized, the quadrant 1 values of those points. And then this is the one that I'm thinking of, okay, I'm in quadrant 3. What kind of sign should I attach to those two values? Make sense? Okay. The point coordinates for -π/2. This is a quadrantal angle. -π/2 is this one over here. What are the points? 0, -1, and that's the answer. Got it? Now, in the next example, we're not going to go and show every single coordinate of our points. We're actually going to ask questions about the individual coordinates. So how are those questions formulated? Are usually formulated like this. State the exact value of cosine of 5π/6. Well, remember the cosine of 5π/6 comes from the point cosine 5π/6 sine 5π/6, right, on the unit circle. But the question only tells you to give what this is. So you don't need the other one, right? But again, this is where you take it from the unit circle of the family of angles of 5π/6, right? So 5π/6 is that one over there in quadrant 2, which is the same family of angle with π/6, right, which is 30 degrees. So what are those values? Let's see. The way it's like the way you write it fancy, you write like this: cosine of 5π/6 equals cosine of the theta r, which is π/6. But then you add the signs, because if here it's a positive, remember the point is square root of 3/2 and 1/2. Here it's going to be what point? Negative square root of 3/2 and 1/2, because you're in quadrant 2, right? So the way this equality works, true equality, is if you put that negative there. So cosine of 5π/6 equals negative of the cosine of the theta r. Make sense? Which equals to -√3/2. Okay. Tangent of 225. 225 is 45-degree family of angles. Which quadrant?
3.
3. Quadrant 3. So tangent of 225 equals tangent of 45 degrees. Now, let's introduce the cast rule because we haven't really used it up to now. Cast rule is this, like that. You start with the C in quadrant 4, and you just write the word cast, like right there. And now, because I want a value of tangent, the actual value, positive or negative, I'm looking at the letter that's in that quadrant, guys. So we say it's T, that means tangent is positive in quadrant 3. So don't have to think about which one is X or Y. You have to divide them, same signs, you know, it's a little bit faster, especially for tangent, okay? So positive, okay? And the tangent is a 45-degree one. It's the easiest one to memorize, 45-degree one. sine of negative pi over 6. Pi over 6 again. Negative pi over 6 is right there. Same as that one, which is again square root of 3 over 2, 1/2 the point. So sine of negative pi over 6 is the same thing as sine of theta r, which is pi over 6. Now, positive or negative? Negative, because again, if you use the CAS rule, again, you start with the C in quadrant 4. That means only the cosine values are positive in quadrant 4. The other ones are negative. And we're looking for a sine, right? So it's going to be negative in quadrant 4, which equals to sine of y values. So negative 1/2. Clear? Now, these are the kinds of questions like individual questions for each of the values. And then we're getting to questions where we combine them a little bit. The first combination is we're doing a squared of the same function. So when you see cosine square of pi, that just means you have a cosine of pi, whatever the value is, you square it. So just the same or similar notation, okay? Pi is there. That's the angle at that point, which is -1, 0. And the cosine value is the x value, right? So we're getting -1 for cosine of pi, and we have to square it, which gets us to 1. Okay, then we have D here, another combo. We have square root of 3 times tangent of 2 pi over 3 minus sine of 7 pi over 4. So what I would do if I were you, I would split them up into individual calculations of the individual functions. So one would be find the value of tangent of 2 pi over 3, and then I would have to multiply by square root of 3, but I will only do that once I know what it is, okay? And then secondly, I would do what is the sine of 7 pi over 4. And then third, I would put them all together, right? And depending on the question, you might have multiple steps, and not only 3 steps, you might have more than that, but always kind of isolate the types of calculations the way we first introduced them. Okay, so tangent of 2 pi over 3 is tangent of pi over 3, because again, I only want to memorize the first quadrant. The other ones, the other values are the same, just differently signed, okay? And I want to decide if here I put a positive or a negative for this equality to be true. So we're doing 2 pi over 3, which is quadrant 2. And the point that we have to use is the 1/2 and square root of 3 over 2 for the pi over 3 family of angles. So if I'm looking to use the CAS rule, only sine values are positive in quadrant 2. All the other ones are negative, right? Including tangent values. So I'm just going to put a negative there. Make sense? That's a quadrant 2 angle. And now, negative, and it's your choice. Have you memorized the value of tangent in the first quadrant? Or do you want to go through the process doing y over x? It's up to you, right? Because if it's y over x, you do square root of 3, square root of 3 over 2 divided by 1/2, and you end up with negative square root of 3. Or if you don't want to do that, then you have to remember that it's square root of 3 for that particular angle. Clear? Okay, so one step is done. Second step is sine of 7 pi over 4. 7 pi over 4, family of angles of pi over 4. Which quadrant? Quadrant 4 right here, a voice, that's the angle, that's it. We use the one in this one. So it's gonna equal to sine of pi over 4, positive or negative? Negative, because again, CAS rule means only cosine is positive in quadrant 4, the other ones are negative, okay? So negative for sine. Now, what is sine of pi over 4? Straight from the unit circle points. Root 2 over 2, and negative because we're in quadrant 4. Second step is done. And then lastly, for this question, we just put it all together. We say square root of 3 times the tangent of 2 pi over 3, which we found it to be negative square root of 3. From step 1. And then minus negative root 2 over 2. Right? Yeah, this one will cancel out. Now the first multiplication here, you have a positive times a negative, which is a negative. Root 3 times root 3 is 3. Then here you have negative times a negative, which is a positive, root 2 over 2.
That's the final answer. Should we go further and go 6 to negative?
Yeah, I would go one step further. Yeah. Then you're gonna write it as a common denominator, 2. And then you have to amplify here by 2. So negative 6 plus root 2. Yeah. How far up? All the way, just let me, let's wait for everybody to finish the bottom and then I'll go back to tangent.